The final structural component of our project that we're going to be drawing is a gazebo. Now, in previous years, we've done pergolas, and I just wanted to show you an example of that. Now, this is done upside down just because of the UCS coordinates, but we're going to use some of this information when we're actually drawing our gazebo. And typically, gazebos are structures that are open-sided and may have 6 or 8 sides, like this one here. And as such, it has some complexity to it when you're drawing because you have to draw it from 2 different angles, one from a straight-on view and one from a side view, and then we have to extend all the lines. However, for the purposes of this exercise, we're going to draw a very simple rectangular shape gazebo, and with that, I have some simple calculations that I've already done to allow you to create the shape with the structural components. And these are a rough guideline. They're only for the purposes of this course. They don't meet code. There are so many different variables that once we do enter into understanding how the code is designed, you'll see how we can actually calculate it. But for now, we're going to be using this table or this chart. And this table and chart refer to several different components. So let's take a look at what these components are. And I'm going to open up this menu here, and this menu here has a number of different images. So this is a rectangular gazebo, and we see the posts, the actual beams, and then the roof rafters. And these are all components that we're going to be looking at for this particular project. And when we're looking at the actual picture, and I'm going to basically zoom in on this thing here. You can see there's a post component that actually supports a beam, and the beam runs the length, and then the rafters slide down from the ridge of the roof down over the beam, and then you have a fascia board on the edge which finishes it off. So you can just take a look in there. You can see the actual rafters that come down over top of the beam. And the post itself is usually designed size-wise based on the size of the beam because it must be able to support the entire width of the beam. You can see here we have fairly large gaps or spaces. So the center-to-center distance here is what I'm calculating here. And I've got 8, 10, 12, 14. And the dimensions I've given here are 8 feet or less, 10 feet or less, and so on. And I've specifically designed the post size so that it will actually be able to support the beam sizes. So in this particular case, we have a beam that's running along one length and the other length because this is what's called a hip roof. It doesn't go straight up like a gable roof. It goes like a hip roof. So we're going to have beams on either side. So on the short side here, maybe this is 10 feet. We can get away with a beam that's less than 10 feet. We can either use 3 2x10s or 2 2x12s. But on the long side, let's say if this was 14 feet, we'd have to then move to the bottom of the chart here, which is 4 2x12s if it's slightly less than 14, and if it's greater than it, we'd use 5 2x12s. So how do we make the choices? We'd like to have the beam size the same in both directions. So if I have a long span here where I require a 2x12, so the 12 to 15 foot range, then I should be using a 2x12 in the shorter side as well. So I make a nice square component, but I don't need as much wood to support that structural length or structural load that's coming down here. Okay, so let's move on. This is another post. This is more of a rectangular one, and you can see what happens if you take a look right in there. I'm going to see if I can zoom in on this. Take a look right in there. The beam sits right on the post. And depending on how we notch this post to support the beam will basically determine how it will look. And notice how you don't see the ceiling joists in there because they actually sit on top of the beam. Let's see if I have another example. This is actually an example I'm using only because it's revealing the joists. And the joists actually sitting. They're notched out and sitting on the beam. Now, typically we cover this. We use a fascia board, but it may be a nice look to have this exposed. These are actual structural braces which reduce the spans, and we'll talk about that next semester. But you can see how the joist sits right on top of the beam. Now, they're using a different type of notching method, but that's okay. They just are using something that's slightly deeper. And you can also see the fact that the joists, the ceiling joists, hang over the beam. So the beam isn't located right on the edge. You'll notice here what I've drawn is the post and the beam, but the actual roof will extend over that edge. It extends anywhere from 12 inches to 24 inches from the center of the beam out to give that overhang, that extra coverage. So you can get extra coverage by bringing the posts in, but allowing the roof to slide over top of that. This is another example that reveals sort of how the ceiling joists sit on top of the beam. Now we have to keep this in mind as we're working through this project, because this is what we've got to draw, and I'm going to keep this handy so as I'm working through the project you can see exactly what I'm talking about. Okay, so now I'm ready to draw my gazebo. I've selected a size, and in my case I'm going to have something that's 10 by 12. Okay, so I'm going to draw the top view of this. I'm going to pick the rectangle tool, to click somewhere on the drawing and type in at 8 feet, 12 feet. So there is my gazebo, and you see there's a long side and a short side. This is where the posts are going to be, the centers of the actual post. So I have to determine what post size I'm going to have. If I know that my long edge is 12 feet, I'll go to the chart where it says 12 feet. There it is, 12 feet. And you'll notice I got a post here of 9¼ inches. That's a 10-inch post. And that seems to be ideal for this size. And I'm going to use that in both directions. It doesn't matter if the shorter one is a smaller post. We're not going to change the post sizes because they're going to not only serve the long side, but the short side as well. So let's go in here. I'm going to copy this. And the only reason I can do this is because I've created this chart. And now I'm going to place my posts. Okay, so this is the center line of the beam and the actual posts. But what size beam am I using? Well, in the 12-foot direction, you notice here 12 to 14 or just less than. I'm right at 12, so I'm going to go with the 4 2x12s. Well, each 2x12 is 1.5 inches thick. So if I do an offset of 1.5 and I do 2 inwards and I do 2 outwards, you can see that those 4 ply beams will fit in both directions. Now, I don't need that in the 8-foot direction. In the 8-foot direction here, I only need 2 of them. So I can go back here and reduce this, but in order to do that, I need to explode this. Now, some people will just leave it like this because it's nice and even all the way around. Or what you can do is actually reduce the numbers. I'm going to do that here just because it gives you the option of doing that. And I don't need the 2 other ones. So I'm going to decide, do I want the beam heavily on the outside or the inside? Well, I want it on the outside just so I have a consistent look. So I'm going to get rid of these 2 lines. What am I going to do with the other 2? I'm going to extend them into the joists of the other 2. So that's how they're actually going to configure together in the one direction. And I'll do the same here. I'll get rid of the 2 outer joists. And I'll extend to here, the inner joist. And that way I have the correct number of ply and size of joists in both directions. And this is really the only place I'm going to see it. I'm not going to see it anywhere else. And we will cut the post and we'll notch it out so this outer part of the post will actually go up and beyond the actual beam itself. So, but we'll take a look at that later. So now I got to determine what size ceiling do I want? Like the roof overhang contributes to that ceiling, not to the span of the joist, but to the ceiling itself and how big that ceiling is going to look. And I may want a 1-foot overlap or a 2-foot overlap. And so I'm going to create a rectangle. And this overlap is typically called an overhang. So offside 12, taking this outer line, offsetting it 12. So I'm going to have a fairly smaller shape overhang roof, and I can have up to 2 feet from the center line of the post where it supports. But this is good. This is going to be the top of my gazebo, and I'm using this as an overall thing. I'm looking at the structure, I'm looking at the shapes of everything, and now I've got to draw the actual roof itself on top of this. So I'm using this to draw everything at once, and then what I'll do is afterwards I'm going to remove or create hidden lines to define all the other elements. So to draw the roof, what we do is we actually draw 45-degree angle lines from the 4 corners. Now I could just draw 2 and then mirror it. It doesn't matter. And I'm going to fillet those 2 lines together. And I'm going to fillet those 2 lines together. And then I'm going to draw vertical line between those two ridges. So this is what I've basically drawn. I've drawn that line, that line. See how it makes a triangle here? That's this triangle here. And then there's a flat section here. That's this line here. And then you can see this is not a or a triangular shape. Two sides that are different lengths, and then the opposite ones are the same. So here's my four-sided item. So this is what I've drawn from the top view here. Now I can start working on the elevations. Okay, let's move that aside. How do I draw the elevations? So the elevations are actually drawn from this shape. And I'm going to use a series of construction lines to develop my elevations. And the simplest thing I can do here is I'm just going to take this outer edge here. I'm going to offset that about 6 feet. It doesn't matter exactly what the number is, but what I'm creating is my drawing plane or my drawing surfaces and how this is actually going to look in elevation. So I'm extending these lines. Notice I'm doing everything in one layer because I'm going to be adding things, subtracting things, modifying things. I'm going to take that, and I'm going to change their color even though I'm in the gazebo layer. I'm going to overwrite that color to red so I can see the construction of it. And now I can draw that particular shape. Well, yes and no. What I've got to determine is the angle of everything I'm drawing here. And basically what we have here are 45-degree angles. So what I see in plan is also what I'm going to see in elevation. Now, why did I come up with that 45-degree angle? Because that's what the roof line angle is on the house. And you can simply click on Tools, Inquiry, and there's an option here, Angle, and then select that. If this angle between these two lines is 90 degrees, which it is, that means the angle of the slope is 45. Okay, so I'm going to go back to this drawing. I already know these two are at a 45-degree angle. So I'm going to take this and copy these two lines down to intersect with this construction line that I have made. So I'm going to select perpendicular. And I'm going to draw the horizontal line. And then I'm going to draw the fascia board. So remember, in this particular example, there was no fascia board here. The fascia board is a covering, so we don't see the ends of the joists. All right, so how big is a fascia board? It could be either a 6 or an 8-inch. I'm going to use a 6-inch for now because of the scale of this. So a 6-inch board is only 5.5 inches in width, so I'll offset that 5.5. Select offset 5.5. And there's my fascia board. That looks good in proportion. If I went with an 8-inch board or 7.5-inch dimension, it would look off. And that's what that side of the roof looks like. Okay, how do I draw the other side of the roof? What is that going to actually look like? Let's draw some extension lines, and then we're going to extend those extension lines to project the image in other directions. So how do we do that? Okay, I know that this particular line here, I bring those across, and I bring those across. And what I'll do then is I will draw a 45-degree angle line. Now, there's different locations where we can draw this 45-degree angle line, but I'm going to pick this location here. And I'll type in, I'm just going to pick a number, 20 feet less than 45. Not quite make it all the way, so I'm going to extend it all to here. And what this allows me to do is either mirror images or draw images one-to-one by extending lines. I'll show you both ways. So if I take this point here and draw it across, and this point here and draw it across, and I take that point, draw it down, and that point, draw it down, and this point and draw it across. Oops, I missed the line here. That length is that length. So that's one way of doing it. I can also take this and mirror that image. So I'm going to select mirror, and I'm going to pick the design elements, the strategic elements of that roof, and I'm going to mirror it from here to here. And you notice it's upside down, no problem. What I'm going to do is mirror the back side of it. And that will actually show up in the correct direction here. Now, because I mirrored the backside and the way this actually worked out, I'm just going to move this from here to here. So that's one way of doing it. I can either extend lines in one direction, extend in the other, and you see if this all works out, if I did this all right, if I copy these two lines here and that edge from there straight across, look at that, it hits it right on. Perfect. So I'm also going to copy this end from there to there, and then I'll extend that to here as well. There we go. So notice, depending on where I put the mirror line, that mirror line determines how all of this is going to come together and where it actually reflects. But basically, I've now drawn this side view over here. Great. What about the next steps? Okay, so I'm going to draw the posts, and the simplest way to do this, I'm going to copy these two posts. I'm copying it from any point above, straight down, to meet this perpendicular. Now, notice how the roof overhang here, is the same on both directions. So I can copy now this item from there to there, and copy this item from there to there. And those posts will line up with these two posts on this side as well. And it may look like, you know, it doesn't. Sometimes it's an optic illusion. And I'll just mirror this to show you how they nicely line up. And once again, I'll use this mirror line. See where they are? They're lined up perfectly in line with these posts because we're using all the right techniques. Okay, what now? Well, I have to decide how much height I want for my clear space. And this is the height that's going to be well above the beam. So if I want an 8-foot height from that line, I can select offset 8 feet. And this is down to the paver or to a deck, depending on what you're putting it on. And now, since I drew that all together, I can stretch these posts from their base perpendicular down to the height. And there we have the posts. So when you're looking at this diagram here, I've drawn the posts. Now these posts are going into the ground, which isn't really a good technique, only because they're going to rot after some time. You can see these posts are actually sitting on pavers, and they've covered the base because they've got some steel support underneath, which will go to a sonotube. And in order to cover the mechanics, the mechanical features down there that may not be exactly attractive, they've put basically a base. And that's a nicer effect than this. This may have been buried right through, which again is not an ideal situation. Putting some sort of base to cover how you've actually put it in makes a bit more sense. In a deck, that construction, that mechanical mechanism is below the actual construction of the deck itself. So we have a number of different decisions to make here and how this works. Now, what about this beam? Well, we've drawn this in our top view because that's what we want to see, and we can dimension it. We've drawn this in our side view. Now, what we can also do is draw the sectional view. So I'm going to copy this over, and I'm going to use the same sort of distancing in between here. So from there to there, and let's draw the section. Okay, when we look at this drawing, we are basically seeing the finished outline, but the actual pergola itself has many different layers to it, and the different layers are the construction materials that allow this to be put together. Now here's the diagram I've got here that shows sort of the fascia, the joist coming down on top of the beam. Notice how the joist, this is a good drawing in this regards. I'm just going to zoom in on it. The joists are notched out to sit on top of the beam, and then they come down and they support the fascia board. Now, it's a good overall drawing. It doesn't get into the specifics I'm going to, but this is essentially what we're going to be drawing as we work through this project here. Okay. Now, what wasn't included in there are the finishing materials. You have asphalt shingles that sit on top of this, and you're going to have the structural joist below it. So The asphalt shingles actually sit on top of this. When we draw this gazebo, we actually draw it to the sheathing level, and then we apply the shingles on top of that. So let me show you how that works. We're going to convert this to a sectional drawing, and we work from the outside in. So asphalt shingles or cedar shingles could be shown as a 1/2 inch thickness typically, or a bit more if you're using any sort of cedar shingles, and that's how we're going to draw that particular element. It's about a 1/2 inch in thickness. Now there's multiple layers here, and we don't need to show it. And we will note the different finishes, but we won't actually draw them because this shingle sits on top of, it could be an ice and water shield or building paper, and then you've got the plywood. And in this particular case, we're going to use not 3/4 inch, 5/8 inch plywood. And the plywood thickness is the sheet that comes downwards. And hopefully this will make sense as I work through this. This fascia board is usually a 1x6 or 1x8, as I mentioned. Well, 1 in thickness is actually only 0.75. 0.75. There's my fascia board. My fascia board is square. So the plywood will actually end right there. And then we'll square that off from here. Perpendicular. And you notice that it doesn't quite meet this corner. We actually put in a piece of metal that is specifically designed to do this. It's a drip edge, and it's designed to cover this configuration so it's nice and clean. So let me show you what a drip edge actually looks like, and you can see it right here. Now, they've placed it on top of the ice and water shield, which is, in my opinion, incorrect, because the ice and water shield should come right to the edge of this and overlap the nails that you're punching through both. This is actually counterproductive. This is the proper way of installing it. You have the roof sheathing, you have the drip edge, then you put the ice and water shield on top of it. And this piece of metal, this metal has different sort of features to it. So you'll notice where you actually put in the nails back here, there's ridges. And those ridges prevent, even though it's on a slope, when you have high winds, the water wants to migrate upwards. And those ridges provide basically a seal between that and the ice and water shield and protects this corner where all this wood is. So you can see how this ice and water shield will work right in this corner to protect this corner. It's very vulnerable to the elements, and it comes down in front of the fascia. And the reason it comes down in front of the fascia is it provides a secondary drip edge for the water to drip down and not migrate upwards. And that's really what it's doing, is it's protecting that edge from water coming up and destroying this. And that's typically where in old construction roofs are damaged. So now I'm going to provide the ceiling joists. And the ceiling joists here I'm going to use 2x6s just because it's not a very large ceiling. And a 2x6 is 5.5 inches in thickness. So I'm going to offset this line 5.5 inches. And here I'm going to provide a cut so these things don't come straight down and go below the fascia level. So typically the joist will end about 1 inch, 1 inch offset from the bottom of the fascia board. So I'll draw that here. And now I can fillet this corner. And this will end right at this line. So the actual joist itself, and I'm going to extend this down here. The actual joist itself has this unusual shape to it, the end cuts, and this is at a 90-degree angle. This will sit on top of the beam. So we're drawing the long edge, and we're going to see the short edge of the beam. But I'm going to draw the bigger edge of the beam here. So it's 4-ply 2x12s. I believe that's what we're using here, 4-ply 2x12s. So I'm going to draw that here, and you'll be able to see it. So I'll just create a 1.5 by, and a 12-inch is actually 11.25. So we're drawing the actual size of the beam, and I'm going to draw the line work. This shows that it is a structural component, and there's 4 of them. So I'll copy all that. And just for simplicity's sake, I'm going to take that and group it. So I right-clicked on it, group. Now it's a single entity. Okay, how is that going to sit on the beam? Well, we've decided to put that 4-ply right in the center of the beam. So I'm going to move this, first of all, to position it. So there's the center point there. And then the center of the beam is the midpoint because I used the rectangle tool to have it. Now, how high does it go? Well, the way it goes is basically we want to move this so I have at least 3 inches, at least 3 inches of the joist sitting on that product. So I'm going to move this upwards, and that's the minimum. See, those two are 1.5 inches thick each. That's the minimum. If I bring it way up, I've cut too much into the joist. So that's the height I want to put it at. So I'm going to go beyond the edge so then I can move it from that midpoint down to where it intersects. Now, if I needed a wider ceiling joist, let's say an 8-inch, which is 7.5 inches. Let's see how that one sits. Offset, 7.5. It's always from the sheathing line down. See how that nicely fills that? And I may want to use that just because it's obviously stronger, especially along the long leg. Although this roof isn't that big, realistically speaking, a 2x8 can, or 2x6 can easily support that. And next year we're going to look at tables and charts that will help us identify exactly what size. But a 2x8 would work as well because it sits nicely on there. I'm going to stick to my decisions that I made earlier, and now I'm going to take this line and trim it. Now, this is a single entity. There's a couple different ways I can trim. Like any time we're creating something, I want to introduce new elements. This is the break command, and the break command allows me to pick a line and then pick 2 points. And what it is actually breaking that line in that specific area. But notice I've gone onto the left side of it. The better way to use this is this. I'll select Modify, Break. Now there's 2 of them. This is a single break. This is a double break. And I'm going to click in the middle of the line, and then I'm going to remove that. And then this line, I can simply click and click its nodes. And there's the cut. That actually gets cut to sit on top of the beam. And that's how we transfer the load from the ceiling joist to the actual beam itself. And that's an important notch because that notch allows us to transfer that load. That notch allows us to transfer the whole load of the roof onto the beam. And that's really what we need to do. Now you can see in the corner, we have a very unusual notch there too because the post is there, and we've got to provide these hip rafters, and those hip rafters come at an angle where the different ceiling joists angle into it. And that's what we have here. So there is our section, but I need to support that, and I'm going to be supporting that with the beam. I've got a couple decisions to make here. How is that post going to be notched out? So when we take a look at this, you'll notice that the post actually comes outside of the edge of the beam. So I may want to cut that all that material out so I see the post go all the way up. So in this particular case, I want to have that post go all the way up. The post itself is going to sit to the underside of the beam itself, but then I want to have line work, and I'm going to draw a polyline here. I want the line work to do this. I want it to go all the way to the top of the beam and then down here. And that way I will have to trim the line I just did, that beam. And I'll also trim that line. Now anything below it is really a hidden line. See, we also have, there's the fascia board in the front. We also see it from behind, and we're going to get to that detail a bit later on. Okay, so here are some of the elements, and I can mirror this over, but we're just drawing a section. I only need to see part of this. This is the only part that I need to see. I will need to see the joists coming down in the other direction, and they're coming down in 16-inch centers. So let's make that decision here. In order to understand how that joist is going to look here, we have to visualize what we're actually going to be seeing. And when we're visualizing what we're actually seeing, it'll help us determine exactly what we're going to be looking at. So in this particular case, we're cutting through this, we're looking at the back. And if I look at the back, I see the beam, and then I see the joist coming down above the beam. Okay, so let's draw that. The joists are going to be 2-inch by 8-inch, and the width of them is 1.5. So I'm going to draw something here at 1.5, comma, and I'm just going to make it 4 feet for now. There it is. I'm not going to see anything past the edge of this beam. In fact, this beam I'm going to see this entire length. So I'm going to do a couple things first. I'm going to copy a line rather than draw them. Copy this line. That's the back side of the beam. There's the lip of the edge of the beam. Nothing behind that am I going to be able to see. This is the fascia board. That's this board here. And along the back, all I'm going to see is a very short section of the fascia board. So I won't see it back there. I'm going to see it between these two. I'm going to get rid of this and that and that. So that fascia board runs behind this joist because I'm not going to see it. And here's the front of it. Now somehow I removed this line when I trimmed it. I forgot to add another cut line. Okay, so there's the fascia board. Now the ceiling joist. Now that fascia board, the bottom end of it, I also won't see in between the posts. So I'm going to trim to the post that line. Good. Now I can take this and move it. And I'm going to move it to the edge first. And then from the edge, I'm going to offset or move that 16 inches because they're going to be at 16-inch centers typically. At 16, less than 0. Now here, it's almost completely hidden. So that really doesn't do us any good. So I'm going to move that again. I'm going to move this. Now I drew it at this corner, so I know it's going to be 16 from that point to where it's supposed to be. And the only part of it that I'm actually going to see is the part that sits on top of the beam. So I will move this from there to there. And we can create or construct a whole bunch of hidden lines to show how this will come down. I will see just the bottom of that. So if I copy this line here, I will see the bottom of that joist right there. Look at that. So let's move this once again and then we'll trim it. That should go to that. So I made a temporary construction line. And then I'll trim what I don't want. I don't want that. Nor do I want that. That's what I'm going to see. So let's try to make sense of this. Here's our ceiling joist. Now I'm using the term ceiling joist. It's a ceiling joist if I'm using any sort of material underneath this. So if I plan on cladding this with cedar planks, this is a cedar joist. If I don't plan on cladding anything underneath and leaving it open like I'm drawing here, then it's actually considered a rafter. And those are two terms we're going to be studying a bit more next semester in what's involved in that. So now I'm going to copy all of this at 16. There we go. And then I will extend that. Now I may make another one here just in case my section is a bit bigger than what I anticipate. Again, same point distance. And then I can extend. We're using, once again, 16-inch centers only for the purposes of demonstration. We may have calculated it to be 12-inch centers. But there we have our section. This is what we're going to see inside as it's being built. The beam is heading towards us. The post is going to be notched out. The beam along the back wall is going in that direction. The ceiling joists that are sitting on top of this are going to be notched out. Therefore, we don't see it until it sticks out. The bottom of it sticks out to the point that we've cut it here. And that's how you draw the section of the top half of it. Now, what about the bottom half? Well, I'm going to use a standard detail. We've used these details before in other applications. I'm going to use a standard detail here, where it's simply a concrete sonotube. So I'm going to copy this. I'm going to take along as much as I can with me and then see how it actually looks when I get to this end. And you may not have the luxury of this, but you could copy it basically from our original drawing of the gate post and rotate this. And it rotates 180 degrees. And if this is my paver construction and this is my post construction, I'm going to move one to the other. And I can tell right away that this post is actually too small. Or sorry, the saddle that I have here is too small. And therefore, this detail won't work. I'm going to have to modify it, edit it, copy it, change some of the configuration of it. That's okay. Let's get rid of that. Get rid of this. And I'm just going to use the stretch command. Now, depending on which actual Simpson strong tie configuration you use, which actual metal device you use, this may look completely different. I'm just using this as a standard detail for our purposes this year. Now, typically there's a 1-inch offset in here. This is not shown using that offset, and the 1-inch offset is in case water comes down. It doesn't sit along the base of this, it actually drips away. I'm leaving this as is for now, and that will be where it's located. The pavers would come right up to it. I'm just going to copy all of this, including grade, right from the base here to this sectional base. And then I can get rid of that. So there is a section of our gazebo. The thing that's missing here, though, is a footing. And typically a gazebo, because it has a roof structure, needs to have a footing. We're going to do a footing that has a 10-inch width and a 10-inch gap. So I will offset 10 down. I'm going to use this layer, make it current, and I will draw a horizontal line through this. Remember, the offset thickness and the height are the same, so 10-inch height, 10-inch offset thickness. And now I can trim here that line. There, it's a polyline, so it goes all the way around. And then I can fillet this. So from here, I'm going to take all the details from our first drawing that we did on the pillars for the gate, and I'll use all the notations I have in here. When you've got to this point, the next series will actually identify how to put it in the viewports and make all the notations.